Exercise 2.9. This exercise pertains to the rules of indices and particularly the negative indices rule. That rule states that if x is having a negative index m, it can be written as 1 divided by x raised to power m. Okay, applying this rule to part A, state whether the following are true or false. 4 raised to power negative 2. It can be written as 1 divided by 4 raised to power 2, and which can be simplified to 1 by 16. So yes, it is the right hand side. So this one is true. Now part B, 8 raised to power negative 2. It can be written as 1 divided by 8 raised to power 2. And 8 raised to power 2 means 8 times 8, that is 64, which is obviously not equal to 1 by 16 as is the given right hand side. So this is false. Okay, now for part C, x raised to power negative 3. It can be written as 1 divided by x raised to power 3. So this is not equal to 1 by 3x. So this right hand side is not the required right hand side, so that's why it is false. For part D, 2 times x raised to power negative 2. This one. I'm taking the left hand side. Now it can be simplified to 2 divide times 1 divided by x squared. So the answer should be 2 by x squared. And on the right hand side that we are given with, that is 1 by x. So that is not equal to 1 by x. So that one is also false. That was question number 1. Okay, now question number 2. Write each expression so it has only positive indices. Part A can be simplified to 1 divided by x squared. So the index is positive. So that's it. Part B can be done exactly the same on the same pattern. 1 divided by y cubed. Now for part C, xy whole raised to power negative 2. We can write it down 1 divided by xy whole squared. Sorry, that was a verbal mistake. It is negative 2, not cubed. So now this can be simplified to either exactly on the same pattern xy squared, or we can split it to give us 1 divided by x squared y squared. This one is correct as well. Also this one is correct. Okay. Now for part D, this can be simplified to 2 times 1 by x squared, or you can write it down as 2 divided by x squared. So the index would become positive. In the same way, this is to be done, this is to be done, and this part G, 8x would be the same. The negative index is just on y. So we can write it down 1 divided by y cubed. Now we can simplify it to give us 8x divided by y cubed. That's it. Okay. And now for part H, 12 would be the same. Then 1 divided by x cubed for this one. And then for y raised to power negative 4, we can write it down 1 divided by y raised to the power 4. So this is 12 divided by x cubed y4. So that is part H. Now it is question number 3. Simplify, write your answer using only positive indices. So part A, we would be applying the rule a raised to the power m times a raised to the power m. When we have got the same bases being multiplied, then their powers get added. So m plus n. So applying the same rule, we can write it down as b raised to power negative 3 plus 4. And negative 3 plus 4 is 1. So we should be writing it down as b only. Okay, now for part b, we first of all need to multiply the coefficients. So 2 times 3, that will become 6, and then x raised to power negative 3 and x raised to power negative 3 being multiplied with each other. So this will be exactly on the application of this rule, x raised to power negative 3 plus this negative 3. So I'll be getting it x raised to power negative 6. 6x raised to the power negative 6. You need to see that this negative 6 is just the index of x, and this 6 is occurring as a coefficient, as a multiple of x variable. That's why. Okay, now part C, 4 divided by 12. Okay, first of all, let me write it down like this: 4s cubed divided by 12s raised to the power 7. Now you can easily cancel these coefficients on the table of 4, and 1 by 3 is the same, and then you see this is the smaller power and this is the larger power. So I can simplify it to 7s raised to power 7 minus 3. So 1 by 3s raised to the power 4. Now the index has been written as a positive number, so that as was required. Now part D, h raised to power negative 7 divided by h raised to the power 4. This being the smaller power would be shifted in the denominator. So I'll be having 1 divided by h raised to power 4 dot h raised to the power positive 7. Then these would be solved using this rule, h raised to the power 4 plus 7, but in the denominator. So 1 divided by h raised to the power 11. So variable h is having positive index, and that's it. And for part E, 2 raised to power negative 3 and x square raised to the power negative 3. That will give us 1 divided by 2 raised to power 3 and x raised to power negative 6. So this is 1 by 8 x raised to power negative 6, which will be solved to x raised to power positive 6. 1 divided by 8 x raised to power 6. That's it.